Hi guys, I want to teach you some steps to factoring so that you can avoid the guess and check if it's just wearing you down. So before I can teach you how to factor trinomials in the form ax squared plus bx plus c using this method, first I have to teach you about grouping. So we'll take a look at grouping with 4 terms. Here we go. So here are the steps if you want to write those down. But the gist is you use grouping when you have 4 terms. So first you got to have 4 terms for grouping to work, which we have here. So step 1 is you make 2 groups. So you just break it up into the first group and the second group. Now it's important that whatever this sign is here goes into the group. So if it was negative, we'd want it in there. And we always separate the 2 groups with a plus. So keep signs with the terms. Use plus in between. So then we're going to factor the GCF out of each group. So the GCF in this first group is 7p squared, and we'd be left with p minus 2. Put that there like that. And then in the second, we'll bring the plus. In the second group, there is no common factor except 1, so we'll just take out a 1. And we'll have a remainder of p minus 2. So I've used color here to help you see. What you're going to be looking for is a common factor that matches. So we're finding the matching binomial factor. So here it is. P minus 2 is the same in each term. So we have p minus 2 for one of our factors. We're going to factor that out, sort of. And when I factor that out, I'd be left with a remainder of 7p squared plus 1. So that would be our final factored form of this polynomial. We want to always check and make sure that there aren't any GCFs inside. If there are still GCFs in, and we might want to go a little farther, we would want to. We'd want to factor completely, put them out in front. Factor them out and make sure it's factored completely, and so there's no factors left inside any common factors inside one of the final factors. Okay, let's look at another one. All right, so for this next one here, first thing we want to do is break it into 2 groups. So 15m cubed minus 10m squared. And then we want to make sure this sign goes with it, so negative 21m plus 14, and we'll always separate them with a plus. So if we take the GCF out of this first group here, it would be 5m squared, and our remainder would be 3m in the first term and negative 2 in the second term. And the GCF of this other group here looks like it would just be a 7. And then we'd have left negative 3m plus 2. Now, if this happens, if you need to change the signs in one of the factors, so if we need to change these signs so that the 3m would be positive like this one and the 2 would be negative like this one, we just need to change the sign of the factor we took out. So if we make this negative 7, then the remainder would be 3m minus 2. So we needed to change signs. And if you want to change signs in the binomial, you have to change signs of the GCF you took out. So now we have a negative 7 out here. And then now I've got the matching binomial. So if I take out that matching binomial, 3m minus 2, then my other binomial, so I take that out, my other binomial is going to be the remainder of 5m squared minus 7. And then I would check them both and make sure that they can't be broken down any further. No GCFs come out. So that's the finished one there. All right, let's do another one here. We have to be really good at this factoring by grouping before I can teach you how to use this to do trinomials. So we got our 2 groups here. We'll separate them with a plus. Out of this first group could come a 3b squared, and I'd be left with 5b plus 1. And out of this other one could come an 8, and I'd be left with 5b plus 1. So you can see the common factor there, 5b plus 1. And if I factor that out, my remaining binomial would be the 3b squared plus 8. So there's the final answer. We would check for GCFs, make sure it can't break down farther. Now I haven't really talked about that step 5 yet, but that step 5 is you can check your work. So here's the final answer. If I multiplied it back out by distributing, I would get 15b cubed, then I get 40b, and then I get positive 3b squared, and then I get positive 8. So you can see that it matches this first one. This didn't come out in standard form. I'd have to rearrange it, put the 3b squared before the 40b, but that's checking. So it should multiply out. If you factor correctly, it should multiply out to be your original polynomial. All right, one more grouping here. Let's see. So break it into groups. Separate it with plus. Take out the GCF. Over here it would just be an n squared, it looks like. So I'd have 6n plus 7. And over here would be 2 by the looks. And that would give me 6n plus 7. So the matching binomial is 6n plus 7, and the remaining binomial is n squared plus 2. So there's that final answer. The one thing I will say is, and I'll show you some of these in a little while, but check for GCFs at the end and make sure you can't break it down any farther. All right, so let's use that grouping skill to make these trinomials in the form ax squared plus bx plus c a little less guess and checky. So first we're going to do a times c, and we want we're going to find the factors. So a times c is, in this case, it's going to be negative 80. So negative 80 is the number we're factoring. And we want the sum to be 38. Okay, so we're going to multiply a times c. So 8 times negative 10, and that gives us the negative 80. We're going to find factors of that negative 80, that sum to be 38, the b term. I mean, we got to be careful with signs. So if I start making some factors here, for example, I could have negative 2 and 40, and those would add up to 38. Oh, I got lucky. Why did I do that right off the bat? I could have picked, let's see, I could have picked 20 times negative 4, but that would have added up to 16. So once I find the right sum, those are going to be my factors. Okay. So then step 3 is we're going to split the middle term. So we're going to rewrite this polynomial 8n squared, but instead of 38n, we're going to use these two factors that we found. So we'll have negative 2n and then positive 40n, and then minus 10. So we split this b term into the two factors that we found. So they'll both be, whatever this variable is, they'll both have it, because if I combined these two that I just made, I would end up right back where I started. So we're just finding a way to split it into two things so that we can do grouping. So now we'll group our terms. We'll take a 2n out here, so that'll give us 4n minus 1. We can take out a 10 here, and that'll leave us with 4n minus 1. So we would have 4n minus 1 for one of our factors, and 2n plus 10 as one of our factors. I wrote it in a different order this time. That wouldn't make any difference. So it could have also been 4n minus 1 and 2n plus 10. So it doesn't matter which order. Now, you should notice this one's not done. Check for GCFs. And we have one. So we need to take it out. This term here doesn't have one, but this does. So we're going to take a 2 out of here. So even if it was over here, we're going to take a 2 out. So it needs to go to the very front of the list. So a 2 comes out of this one. And I might put the one I'm breaking down next to it. But this one would not change, so it would be 4n minus 1. And this one would be n plus 5. The reason I put it in front over here is because I knew it was going to have a GCF, and it might be less confusing to have this one shown this way with the GCF out, and then the 4n minus 1 left here. So if I multiplied this together, first I would distribute the 2, and I'd end up with 2n plus 10, so I'd be back to here where I started. And if I multiply all of this out, I would end up right back here where I started from. So you should check it, make sure you agree. So 4n minus 1, n plus 5, and 2 are the three factors that are the completely factored form of that trinomial. Let's try another one. So when I multiply a times c on this one, I'm going to get my number that I have to factor. Okay, so that's going to give us our starting number of 108, and we want them to sum to be 24. So let's see, I'll try 2 and 54. That is going to give me 56. That won't work. Let's see, will 3 go in there? 3 will give me 30, that'd be 9, 18, 36, but that's going to give me 39, so that won't work. 4 would give me 2, it would go in 2 times and 28, so that'd be 27, but that's still going to give me 31, so that won't work. 5's not going to go in there. If I try 6, 6 will go in 1 time, then I have 48, so that'll be 18. And 6 and 18 add up to 24. So there it is. 6 and 18 is what I'm going to split this middle number into. So I would have my 12n squared, but I'm going to split my 24n into positive 6n and positive 18n, and then bring down my plus 9. So these two are showing the new version of what used to be 24. So then I'll group these. I guess I don't need to write 2 pluses. I'll just leave that one out there. And 6n comes out, so I'd have 2n plus 1. And let's see, 9 comes out, and I'll have 2n plus 1. So this one I'd have 6n plus 9 as the external factor. 6n plus 9, and what got distributed was 2n plus 1. And 6n plus 9, a 3 can come out, so then I'd have 2n plus 3 and 2n plus 1 for my final factors. I'll just show one time how it'll go back together. So this will give me the 6n plus 9, and then I'll have to multiply it by 2n plus 1. So that's going to give me 12n squared plus 6n plus 18n plus 9. And then when I combine like terms, I'll get 12n squared plus 24n plus 9, just to check my work. All right, so you should try this one, and we'll see if we match up at the end. Be careful with signs. So this time, negative 8 is my a times c, and I need a sum of negative 7. So I'll try negative 1 and 8, but that would give me 7. So a tip is, if we have the right number, wrong signs, right number, wrong sign, then we can just change the sign of both of these that I chose. So if I did 1 and negative 8 instead, then I would get the one I need. So if you get the right number but wrong signs, just change both of those signs. So I'm going to have to use a 4n squared. I'm going to split this into positive 1n and negative 8n, and then minus 2. So when I group it, put a plus in between. I'll take out an n here. That would leave me with 4n plus 1. Take out, now I can see if I need 4n plus 1 as my remainder, I'm going to go ahead and take out a negative right now. So I'll factor out a negative 2, which would leave me with 4n plus 1, so that my signs will work. So I'll have n minus 2 for one factor and 4n plus 1 as my matching factor. And then, let's see, nothing comes out of either one of those, so that one's done. All right, one more, then you're just on your own here. So first I'm going to do 3 times 35, which is going to give me 105, and I need to get a sum of negative 16. So I'm going to try 5, and let's see, I'll do negative 5 times 21, and that's actually going to give me 16. So those are the right numbers, but I'll have to do 5 and negative 21 to get negative 16. So 3n squared plus 5n minus 21n minus 35. Group them. Put a plus in between. Let's see, I can only take out an n here, it looks like, so I'd have 3n plus 5. And here I could take out a negative 7, and I'd be left with 3n plus 5. So my outside factor would be n minus 7. My matching factor would be 3n plus 5. And no GCFs in any of those, so that is done. So that's it. That's all I got. I hope it's helpful. And if you prefer guess and check, it's perfectly fine. I just got tired of it after a while and appreciated this method when someone taught it to me, which was not in high school.